Hello and welcome. In this video, we will be working through some examples of interacting with objects and selections in PyMol 3. By the end of this tutorial, you'll be able to understand the difference between objects and selections in PyMol, create, rename and interact with new selections, isolate components of a structure and extract or copy them to new objects, and style objects and selections with different colours and representations. Let's get started. So we're here in PyMol 3 and I'm going to type fetch 6puz in the command input area to download a HIV interosome structure, which is a large nuclear protein complex. Let's click on the command button in the toggle toolbar to minimize the command log so we have a bit more screen real estate to start exploring this structure. We can see that this object comprises multiple protein chains, a DNA double helix, water molecules which are currently displayed as red crosses, some spherical ions, and a small molecule ligand, which is the integrase strand transfer inhibitor XZ446, or compound 4F. Currently, all of these components are controlled within this single 6puz object, so we're going to isolate the various parts so that we can more easily colour and style them, or display and hide them. We're going to start by clicking the Sequence Viewer Display button, SEQ, in the toggle toolbar to show the sequence. Along the top of the workspace, we can now see a scroll bar and single-letter amino acid code and numbering. The grayed out letters are parts of the sequence that were not included or resolved in the structural determination, so there are no coordinates in the PDB file for these amino acids. You can learn more about structural determination methods and data via the RCSB PDB training portal and their excellent guide to understanding PDB data. If we scroll through the amino acid chain and highlight sections of it, we can see the corresponding residues are highlighted in the structure. Let's start by scrolling all the way to the right-hand side where we can see a large number of red O's. These represent the oxygen atoms of water molecules. Make sure nothing else is selected by clicking on a blank space in the workspace, and then we're going to select all of the red O's. We can see that a new selection, SELE, has been added to the Contents panel. This represents our selection. Making sure not to click on any other parts of the structure, as we only want the water, let's save this selection by clicking on the Action button next to SELE and choosing Rename Selection. In the top left corner of the workspace, we can see the renaming prompt. Use the backspace or delete key to remove the current name, and let's rename this selection Water. Great, this selection is now listed in the Contents panel and we can toggle it on or off. Selection names are displayed in parentheses, and we can tell that this is a selection of an existing object and not a standalone object because toggling on and off our water selection does not hide the red crosses in the same way that toggling on and off the 6puz object completely hides everything from view. We can also create selections using the Action submenu under Generate, or using the Select command if we know how to describe the components of our selection. More on this later. We can use selections to style specific parts of an object in different ways. For example, next to water, click S and then spheres to show the water-oxygen atoms as spheres. If we then decided we actually wanted to turn off all the sphere representations for the 6puz object, we could choose H and then hide spheres. This will hide the spheres since our water selection is currently part of the 6puz object. So the takeaway message here is that selections and the objects that they are part of are linked, and the order that you do things is additive and sequential. What if we wanted these water molecules not to be considered part of the 6puz object? No problem. We can easily turn selections into separate objects. Clicking A, the Action submenu, next to the water selection, we can see the options to copy to object or extract object. Let's go ahead and extract our water so that it's a separate object. Rename this new object Water. Since this has the same name as our selection, the object overwrites the selection. We can now toggle on and off the water since it is no longer part of the 6PUZ object, and we can see that our new object is now displayed as a separate track in the sequence viewer. Sometimes it can be important to keep selections as part of the same object. For example, the action find polar contacts to other atoms in object will not find any polar contacts between the 6PUZ atoms and the water molecules, since these are now separate objects. The copy to options can also be really useful if you want to duplicate an object and make some edits, or if you want to try out some styling without risking having to re-import the full structure or reinitialize PyMol to undo any unwanted changes. Let's finish off this tutorial by creating selections for the DNA, ligand and ions. I'm going to start with the DNA by using the selection mode menu in the action toolbar, and we can use the chains or segments mode here and then click on the DNA. Be sure to select both parts of the double helix. You could also use the sequence track that we used to select the waters and select only the DNA base pairs. Make sure not to accidentally include the magnesium or zinc ions or the XXJ ligand if you're using this method. Rename this selection DNA. Next, the ligand. Select and rename this 4F. Might as well also go ahead and select out the ions. Actually, I'm going to edit this selection by deselecting the zinc ions and creating a separate selection for the magnesium ions and the zinc ions. Great! We can see from the sequence that the integrase protein is made up of several chains. Rather than selecting these out, which we could absolutely do, let's use the C or Color submenu next to the 6PUZ object to color by chain. We could also try out the Color by secondary structure, Color by SS option here, and I'm going to use the second one down so the alpha helices are cyan, beta sheets are magenta, and the loops are pink. Looking good! To ensure our DNA double helix stands out and looks different from the protein, let's color this green. Nice. Now let's colour the 4F ligand by element with yellow carbons. Not bad. Did you know that you can click on the magic wand icon in the toggle toolbar below the contents panel to access a number of handy wizard menus? I'm going to use this to quickly show off the different kinds of representations we have access to in PyMol by clicking Demo and Representations. So far, our protein and DNA are displayed in a cartoon representation, and we've seen and hidden the water and ions as spheres, and the ligand is either lines or licorice sticks. Let's hit End Demonstration, then Zoom All in the Action toolbar, or right-click to bring our structures back into view. Representations can be layered, so next to our DNA selection, let's click S and Show Lines. Now that we can see more than just the cartoon, let's use C to colour by element and choose green carbons. I don't like the DNA colouring and representation here, so let's use H to hide the cartoon just for the DNA. Make the wireframe lines thicker by going to S and licorice. Now the ligand is getting a little lost. Let's use spheres. The waters are currently off, but if we toggle the water object to include them, the spheres here can make things look very overcrowded. Let's hide the spheres and show non-bonded spheres, NB_spheres, so they're not too large. Nice. Let's finish off by adding a surface or mesh just to the protein to see how it looks. Mesh and surface views are defined by rolling a ball or probe the size of a water molecule over the structure to simulate which parts of the structure water molecules could get to. This is also referred to as the solvent accessible area, or solvent accessible surface area. If we try to use the Hide Some menu to hide the mesh from our DNA selection, it doesn't go away. A way to get around this is to extract the DNA selection so it is treated as a different object. Once we've done this, any protein and DNA meshes or surfaces we decide to show will be generated for that individual object. Nice! This tutorial was a really high-level overview of a fraction of the things we can do with objects and selections in PyMol, and we've only really scratched the surface here. We mostly use the Graphical User Interface, or GUI, to create new selections, extract objects and apply styles in this tutorial, but you could perform all these actions by typing commands into the command input area or by writing a script to automate the process, and we will come back to this in later tutorials. For online course participants, a list of the commands is available in a downloadable transcript so that you can familiarise yourself with some of the selection, extraction and colouring commands and have a go at redoing this tutorial using the command prompt rather than the interface. The PyMol Wiki, pymolwiki.org, also has a lot of great examples and whole pages on selection algebra and colouring commands that can be used directly in the command input area or in scripts to automate things. That brings us to the end of this tutorial. You can now understand the difference between objects and selections in PyMol, create, rename and interact with new selections, isolate components of a structure and extract or copy them to new objects, and style objects and selections with different colours and representations. Thanks for watching.